Yes, sir.
All right, everyone is good?
Yes, sir.
All right. We saw the results of the examinations or the test.
No, sir.
You didn't receive your test results that we did in the last week?
Sir, no.
No, nobody. Krishna, Ronaldo, Shikhani?
No, sir.
No, sir.
I don't know how is that possible. But let me tell you. Just give me a moment. Yeah. The results are as Saeed has 10 out of 11. All right, Kulsum has 11 out of 11. Hamza, that means Ronaldo is 7.5 out of 11. Ishan is 6 out of 11. Krishna is 7.5 out of 11. All right. Everyone got the result.
Yes, sir.
Yes.
So how many are happy? How many are sad? How many don't care? Can I get any response? Krishna, Ishan, you did really bad, right?
Yes, sir.
So do you know what went wrong in your paper?
Yes, sir. I think the second question made mistake.
Right. And Ishan, you?
Sir, in last question, I spent too much
Last
time
question.
thinking.
Right. So when you read the question paper, first go through all the questions, right? Find out which one is easier, which one is not. All right. Then try
Yes,
to
sir.
solve this. If you don't know a question and try to solve that, that will be an issue. Right? You will be wasting your time. So think about that, what questions to solve. When you see a question, do you get the steps to solve that question? Like your mind tells you the steps, right? You have to do this, then this, then this. If you don't get that in clear way, don't try to attempt that question in the first try. All right, try to do another question. Most of the students, what they do wrong is they think they will figure out on the way, right? That doesn't happen. Is it clear?
Yes, sir.
The figuring out part is done at home when you are doing the practice. In the examinations, you don't want to try to figure out the questions, right? Just solve whatever questions you can. Then when the time is like you have the time, then try to figure out if you can solve more questions. All right.
Okay, sir.
All right. And I would appreciate that Kulsum has like flawless paper. Right? I would expect everyone's paper like that, like one of the best papers I have ever checked. All right.
Sir, almost all the questions we did it in class.
Absolutely right. Right. We did almost every questions in the class. Only that x square upon x square plus 1 question we didn't do, right?
I didn't attempt that one.
Absolutely. See, that was the trick. If you don't know how to solve this question, why go to a place, right? We are not here bear grylls, man versus wild. We don't want to go to unexplored territory, right? Rest of the questions were solved in the class, and still you guys didn't solve that properly. And Ishan and Krishna, you guys solved this question, right?
Yes, sir.
And you did really bad in this question. So let me solve this question how to first, right? Let's see how to solve this question first. I think we need to. Does anyone have that question? I believe the question was f of x is equals to x square upon x square plus 1, right? Yes or no?
Yes, sir.
And we need the conditions also. Let me get this question. function is from R to R, neither 1 1 nor on 2, right? Krishna, in the class we did like this: f of x1 is equals to f of x2, right?
Yes, sir.
But in the question you solved like this: f of x equals to f of y, right?
Yes.
So any specific reason why you change this?
No, sir. In class, my usual class actually they used to solve like this, so I just got
All
it.
right, all right. Absolutely right. I didn't cut your marks for this, but sometimes what happens is, see, we assume f of x is equals to y, right?
Yes.
So if you want to take like this, then write x and y belongs to R. All right. You skip this step. All right, Krishna.
Okay, sir.
Rest of the thing is clear. You can assume whatever variable you want. Now we will take f of x1 equals to f of x2. So x1 square upon x1 square plus 1 is equals to x2 square upon x2 square plus 1. And Krishna, what you did wrong is you cancelled out this one like this, right? But you cannot do that. X1 square plus 1 is not equals to x2 square plus 1. You have to cross multiply this, right? So this will be x1 square into x2 square plus 1 is equals to x2 square into x1 square plus 1. Ishan, you solved this the right way, but then you did a lot of mistakes. So this will be x1 square x2 square plus x1 square is equals to x2 square x1 square plus x2 square, right? Now you can cancel this out. All right, then you'll get x1 is equals to plus minus x2. So we are getting two values. So one part is clear, I hope, all of you.
Yes, sir.
All right, now range part, that is, or onto part, that is the issue I feel for everyone. But Syed solve this in the accurate way, right? Salva, you solved this question, right?
Yes, sir.
Right. This question was flawless, right? I was very happy to see that you did exactly right. You didn't skip any steps. So we'll assume y equals to x square upon 1 plus x square. Now you have to cross multiply. Y 1 plus x square is equals to x square. Our goal is to write x in the terms of y. So we multiply this. So this will be x square y plus y is equals to x square, right? How we can solve this? How we can solve this?
So we can bring x square y to the other side and take x common.
Right. You cannot just take x common, right, Krishna? Because we have x square, x square. So you can take x square common and write y minus 1 is equals to minus y. So x square equals to minus y upon y minus 1, right? Or you can remove this minus and just write y upon 1 minus y. All right. Then x will be equals to under root y upon 1 minus y. Did I write the question right?
Sir, is it x by 1 plus, I mean x
Right,
square?
right. Exactly right. Nobody is even telling me that. So I think I did this question also wrong. This is x upon x square plus 1. Right? This is x. So you can solve this one. All right, try to write that. Let me just solve this one. So we have to cross multiply again. We have y equals to x by 1 plus x square. This is the question, right? I wrote the question wrong. So we have y times 1 plus x square is equals to x. So y plus x square y is equals to x. So now, Krishna, what you did is you wrote this x minus x square y, took x common, right?
Yes, sir.
But our goal is to write x in the form of some y, right?
Yes, sir.
But if you just take x common, then this will be 1 minus xy. Then you put that quantity in the denominator, right? And you wrote x equals to y upon x minus 1 minus xy. But see, in this, we always have a x in here also, right? We did not have x equals to some quantities of y. Are you getting my point, Krishna?
Yes, sir.
So what we have to do is, let's take everything to this side. So this is x square y minus x plus y equals to 0. All right. Now we have a quadratic equation in x. So you can find the value of x is equals to the quadratic formula minus b, that means 1 minus time minus 1 is 1, plus minus b square, 1 minus 4ac, 4 into y times y, so 4y square, upon 2a, so 2y. This way you can find x equals to some quantities of y. Is it clear, Krishna?
Yes, sir.
Ishan?
Yes.
All right. Everyone else, Ronaldo, Shikani, Kulsum?
Yes.
Yes, sir.
All right. Now we have to check what are the values of y that satisfies there. So you have to check this must be positive, right? Greater than or equals to 0, because under root quantities always take 0 to infinite, right? 0 included. So we have to say 1 minus 4y square is greater than or equals to 0. So this will be 1 minus 2y, 1 plus 2y is greater than or equals to 0. Does anyone know how to solve this one? How to solve this type of equations? Anyone knows this? All right. So first task is to make the coefficient positive of the variable. So take a negative common. So minus 2y minus 1, 2y plus 1 is greater than or equals to 0. All right. Now multiply this negative sign to that side. So we'll have 2y minus 1, 2y plus 1 is less than or equals to 0. This step is clear.
Yes, sir.
All right. Now what we have to do is draw the factors. This we have factor half, this we have minus half. So minus half and half. Plus, minus, plus, always. This is called wavy curve method. Anyone remember this? You must have done this in class 11,
Yes, sir.
right? Wavy curve method. So we need less than 0. That means negative part. So y must belong from minus half to half. All right. And we have equals to also. So close brackets. So y will be from minus half to half. That is why this is not onto. Is it clear?
Yes, sir.
All right. Kulsum, this is clear?
Yes, sir, I get it.
All right. So if you want, note it down. Otherwise, we'll move on. So if you face this type of questions and don't know how to solve this, then it's better to not solve this, right? Because the second question and the fifth question was almost same. All right. Noted this down, everyone?
Yes, sir.
All right. Let's start with inverse trigonometric functions. Today we are going to complete the chapter property 4. Sine inverse half plus cos inverse half is equals to, wait, did I tell you about property 3 or not? I don't remember actually. What was the last thing we did in the class? Just does anyone remember what is the last property I told you?
Sir, that was property 4, sir. Sine inverse of 1 by x. That one.
All right. Let's, so this is property 5, right? I told you that sine inverse x is equals to 1 upon x, right?
Yes.
So we have sine inverse x. Cos inverse x is equals to pi by 2. And here x will belong to, what are the values x will belong to? What is the
Minus 1
domain
to 1.
of, right, minus 1, 2. I need everyone's answers on this. Here x will belong to domain of tan inverse x or cot inverse x. R. Here x will belong to
R minus 1 to
r minus 1, 2. Everyone is clear about this domain?
Yes.
The proof is very easy here. Sorry. We can take sine inverse x is equals to theta. So x will be sine theta. And for sine theta, we can write cos pi by 2 minus theta. This is clear. We can write sine theta is equals to cos pi by 2 minus theta.
Yes, sir.
So we can write x is equals to cos pi by 2 minus theta, or pi by 2 minus theta equals to cos inverse x. And what is theta? Theta is sine inverse x. So we can put pi by 2 minus sine inverse x is equals to cos inverse x. So take this to this side. We have the same identity. All right.
Yes, sir.
So proofs are very easy in inverse trigonometric functions. Write it down. Done, everyone?
Done, sir.
All right. Property 6. Tan inverse x plus tan inverse y is equals to tan inverse plus y on 1 minus xy. And here xy should be less than equals to 1, less than 1. Tan inverse x minus tan inverse y is equals to tan inverse x minus y upon x 1 plus xy more than minus 1. All right, here the proof is also very easy. Let's assume tan inverse x is a. So this will imply x is equals to tan a, and tan inverse y is equals to b. This implies y equals to tan b. Can anyone tell me what is the formula for tan a plus b?
Tan A plus tan B by 1 minus tan A tan B.
Right. So instead of tan a, we can put x, and tan b is equals to y 1 minus xy. Now just take tan inverse both sides. So this implies a plus b is equals to tan inverse x plus y upon and 1 minus xy, and a plus b is tan inverse x and tan inverse y. Clear, everyone? Derivation is clear?
Yes, sir.
Yes, sir.
All right, note it down. Then we'll solve few questions.
Done, sir.
All right, let's solve a question. These properties are very easy. You just have to apply them and you will be solving the questions very fast. Prove that tan inverse 1 upon 7 plus tan inverse 1 upon 13 equals to tan inverse 2 upon 9. All right, try to solve this. Very easy. You just have to use this property. All right, I'll give you a few minutes. Try to solve this. solve this, everyone?
So solve the first one, but second one, can you solve it?
In the second one, take it step by step. Just try to solve this first, then whatever answer you get, add this to this quantity.
Okay. Sir.
All right. And what about rest of you? Ronaldo, Kulsum, Shikani, Said.
Yes, sir. Same, done with the first one.
All right. Tani, in the second one also, just add these two, then the result is added to the third, and you'll be getting the answer very easily. All right. No need for me to solve the first one, I guess. We just have to apply the property.
Yes, sir.
All right.
Done, sir.
All right. Everyone has the answer. Krishna, Said, have you solved this second question?
So last step, sir. Yes, I got it.
All right. No need for me to solve this.
No, sir.
No, sir.
All right. So the third question. What can we do here? Any ideas? See, in here, we are not moving from left to right. We are moving to right to left, right? We only have one tan inverse quantity. So can we convert this quantity into something that looks like this? Something plus something upon 1 minus something something.
Yes, sir.
How can we do that, Krishna?
Sir, X as A and BX as Y.
X as A, all right, and bx as y. But then we will not have 1 here, right? We have b here. For this to apply, we need 1 in the denominator, right? 1 minus something. So how can we make this 1? Can we divide by b in the numerator and denominator? Then this will be b upon b and which will be 1, right?
Yes, sir.
So this will be a plus bx whole divided by b upon b minus ax divided by. All right. So this will be tan inverse a upon b plus x upon 1 minus a upon b into x. Now does it look like this? X plus y upon 1 minus xy.
Yes, sir.
So what will be the answer here? It will be tan inverse a upon b plus tan inverse x, right? Tan inverse this plus tan inverse this. Is it clear, everyone?
Yes, sir.
Yes.
All right. Kulsum, Said, Shikani.
Yes.
All right. Note it down. Done, everyone?
Yes, sir.
All right. Now the next question. We have to prove sine of cot inverse cos of tan inverse x is equals to under root x square plus 1 upon x square plus 2. Any ideas how we can do this? Very easy. Just assume tan inverse x is equals to a, so x will be tan a. Now if we draw a right angle triangle, this will be a, then tan a is x. That means this is x, this is 1, so this will be 1 plus x square. Yes or no?
Yes, sir.
Now can we write tan inverse x as cos inverse something? So if in this triangle tan a is x, then cos a will be, what will be cos a from this triangle?
So 1 by root 1 plus x square.
So a will be cos inverse 1 upon 1 plus x square. So instead of a, what is a? Tan inverse x. We can write cos inverse 1 upon under root 1 plus x square. So we can write this as sine of cot inverse cos inverse 1 upon 1 plus x square. This is clear to everyone? Yes or no?
Yes, sir.
Yes, sir.
All right. So cos of cos inverse is that angle theta. So we can write sine of cot inverse 1 upon 1 plus x square under root. Now again, we can change this cot inverse theta to sine inverse something. How can we change that? By drawing another right angle triangle. Let's assume cot inverse 1 upon x square under root is b. So cot b will be 1 upon 1 plus x square under root. So if we draw a right angle triangle, suppose this is angle B, cot B is what is base upon hypotenuse in that format? What is cot theta? In PBH, what is cot theta?
Opposite by adjacent.
Right. Opposite by adjacent or adjacent by opposite? P upon B or B upon P?
Sir, adjacent by opposite.
Adjacent by opposite, right? Because it is cos theta by sin theta. So this upon this. So this is 1, this is 1 plus x square. So this will be 1 plus x square, 2 plus x square, right? So sine B will be perpendicular upon hypotenuse. So under root 1 plus x square upon under root 2 plus x square. All right. So now we can write P is equals to sine inverse 1 plus x square under root 2 plus x square under root. So this is sine of sine inverse 1 plus x square upon 2 plus x square. All right. So this is equal to 1 plus x square upon 2 plus x square under root. Is this clear or not? So no properties used, only the right angle triangle is enough to solve this type of questions. Is it clear or not?
Yes. Sir.
Yes, sir.
All right. So all the important questions I'm doing in the class. If you still don't solve this when I give you the test, then this time I'll bring a stick. All right. All right, Krishna.
Okay, sir.
Ishan, what about you? This is clear?
Yes, sir.
All right. Note it down. All right, after noting this question down, this is your homework question. Note this down also. Same format. Done, everyone?
Done, sir.
All right. This homework question also.
Yes, sir.
All right. Now we have last properties. Before that, we need to know what is tan 2 theta. Formula for tan 2 theta.
2 tan theta by 1 minus tan square theta.
Absolutely right. Sine 2 theta in the format of tan. There is one sine 2 theta formula in the format of, right?
2 tan theta by 1 plus tan square theta.
Absolutely right. Cos 2 theta in the format of tan. This we don't know, sir. This is very tough.
1 minus tan square theta by 1 plus tan square theta.
Absolutely. All right. So if you remember these formulas, then next property is very easy. So write it down. These formulas. And this is property number 7 or 6. 7.
7, sir.
All right. Two tan inverse. Just note down that one first. Move on and read the page. Done?
Done, sir. So first property is 2 tan inverse x is sine inverse. Look at that formula. Sine formula. We have sine 2 theta. Sine 2 tan theta upon 1 plus tan square theta. Right. Same way, sine inverse
2 tan theta. So 2x upon 1 plus tan square theta, 1 plus x square. Is it clear?
Yes, sir.
The same format we have to put 2 tan inverse x. What will be in the form of cos inverse? Who can tell me? Look at this formula.
1 minus x squared by 1 plus x squared.
Absolutely right. And in the form of tan,
Two x by one minus x square.
absolutely right. Write it down. Alright, you don't have to care about domains so much in this type of questions. All right, we're not going that deep into this chapter. Tell me when you are note this down, then we'll solve few more questions and this chapter will be finished.
Done, sir.
All right, yes, the derivation is also there. So how to derive this type of things? Always look at the right side. All right, in the right hand side, you have sine inverse. If we have to derive the first one, so let's assume first tan inverse x is equal to theta. Always assume the left side, tan inverse x is equal to theta. That means x is equal to tan theta. Now look at the right side. Right side we have sine inverse. So use the formula for sine 2 theta. Always. All right. If you have to prove cos inverse, then use cos 2 theta. If you have to prove tan, then tan 2 theta. This is clear.
Yes, sir.
And tan 2 theta when we are using for 2 tan inverse x. If we have 3 tan inverse x or something like that, you have to use sine 3 theta, cos 3 theta accordingly. This is clear.
Yes, sir.
Yes or no? All right. So sine 2 theta, we have the formula again. We just wrote 2 tan x upon 1 plus tan square x. So instead of tan x, I can write, sorry, tan theta. We have tan theta. Instead of tan theta, I can write x. So 2x upon 1 plus x square. 2 theta will be sine inverse 2x upon 1 plus x square. This is easy. So theta is tan inverse x. So this is 2 tan inverse x is equals to sine inverse 2x upon 1 plus x square. Very easy proofs. Again, in inverse trigonometry, the proofs are very easy. I hope this is clear.
Yes, sir.
All right. Note it down. Already done.
Done, sir.
All right. This question they are saying solve. Solve means find the value of x, right? Solve means find the value of x. You don't have to prove that this is equal to this. You have to find the value of x here. So any ideas how we can solve this?
Using the formula
Which formula?
tan inverse x plus tan inverse y.
Absolutely right. Just use tan inverse x plus tan inverse y. Then try to solve how this goes. All right. I'll give you a few minutes. Use that formula.
But sir, that's going to be very long, right? Is there no shortcut?
No, there is no shortcut. If we take this tan a, no, you can solve that this way. Okay, not long. The calculations are bit. Let me solve this. Let's see how long this is. So this will be tan inverse x minus 1 upon x minus 2 plus x plus 1 upon x plus 2 whole divided by 1 minus x minus 1 upon x minus 2 x plus 1 by x plus 2 is equals to pi by 4. All right, now taking LCM. Right, we have to take LCM here. XM is x square minus 4 upon, this is x minus 1 x plus 2, so x square minus x square plus x minus 2 plus here we have x square minus x minus 2, right, upon we have x square minus 1 x square minus 2, so here x square minus 2 minus x square plus 1 upon x square minus 4, this is 4 is equals to pi by 4. The steps are clear?
Yes, sir.
Yes, sir.
All right. So tan inverse, let's see who are cancelling out. So this minus x square minus 4 x square minus 4. So finally we have x square minus 4 upon this x square and x square is gone minus 3 is equals to pi by 4. Tell me if I did anywhere wrong. All right. So this is x square minus 4 upon minus 3 is equals to tan pi by 4. And what is the value of tan pi by 4?
1.
1. So this is equals to 1. Now the question is very simple to solve. Let me solve it here. So x square minus 4 is equals to minus 3. So x square is equals to 4 minus 3 is 1. So x is equals to plus minus 1. All right.
Wait, sir, it's 2x square, right?
Sorry,
2x square, right?
we have 2x square, right? 2x square, absolutely right. We have x square plus x square, 2x square. Absolutely right. So we have this half here. So this will be 1 upon root 2. All right. Absolute right, Kulsum. Very good. Any more mistakes I committed? I tend to do a lot of mistakes while I'm solving questions online. Please check and solve by yourself also. Tell me if I did anything wrong. I also have the answer here. So let me just check. Yes, this is right. 1 upon root 2 plus minus 1 upon root 2. Right, there is one thing you have to check here. In few of the cases, one answer will be invalid. How to check that? In the question, the right hand side is positive, right? So if you put plus 1 upon root 2 here, plus 1 upon root 2 minus half is negative, plus 1 upon root 2 minus 2 is negative. So negative is positive. This becomes positive. Now in here, 1 upon root 2 plus 1 is positive, 1 upon root 2 plus 2 is positive. So this is also positive. Positive equals to positive. This is valid. But if you put minus 1 upon root 2, so minus 1 upon root 2 minus 1 is negative. Minus 1 upon 2 minus 2 is also negative. So negative, negative, again this is positive. And in here, minus 1 upon root 2 plus 1 is positive because 1 is more than 1 upon root 2. In the denominator, minus 1 upon root 2 plus 2. This is also positive. So again, positive plus positive gives us positive. So both the answers are valid. But suppose in some cases, negative signs gives you negative value, then that answer will be invalid. All right.
Yes, sir.
Everyone understood what I said? Or
So
Yes, sir.
all right. So please note it down. All right, Kulsum, see, not so much long questions, right? 4 steps we needed.
It's fine.
All right, and you will be getting 4 marks for this. So very easy, I think. The easiest 4 marks ever. If you have solved this one, then tell me. This is the next question. Ishan, everything good?
Yes, sir.
All right. Try to solve this one. Same format.
Answer.
All right. Let's see how we can solve this. Again, same thing. Tan A plus tan inverse A plus tan inverse B will be tan inverse 2x plus 3x upon 1 minus 6x square is equals to pi by 4. So this is 5x upon 1 minus 6x square is equals to pi by 4 is 1. So 5x is equals to 1 minus 6x square. So 6x square plus 5x minus 1 is equal to 0. Now you have to just solve this quadratic equation. So we can use middle splitting. 3x plus 2x.
So
No,
6x minus x.
6x, right? This is negative. All right. So 6x x plus 1 minus 1 x plus 1 is equal to 0. So x is equal to either 1 upon 6 or minus 1. All right. So you can put minus 1 and see that that is not okay, because negative and negative will not give us positive, right?
Yes, sir.
So x will be equals to 1 upon 6. I hope this is clear, everyone.
Yes.
Ronaldo, Shikani. All right. Said, Ishan.
Yes, sir.
All right. Let's solve a few more questions. Tan inverse 2x upon 1 minus x square plus cot inverse 1 minus x square upon 2x equals to pi by 3. You have to solve this one.
Sir, can you explain this question?
All right. Any ideas, anyone, how to solve this?
So we can change cot inverse into tan.
Absolutely right. So for the first step would be,
Sir, please say the formulas also when you are answering.
all right. See, Shivani, do you remember this property? Tan inverse 1 upon x is equals to what happens? Cot inverse x, something like this. This was property number 3, I guess, 3 or 4. Shikani, remember this?
No, sir.
All right. So please remember this. Otherwise, you will not be able to solve question. So if we reciprocate the data, you can change tan into cot and sine into cos and so on. Sine into cosec and sec into cos, so on. So we can write this tan inverse 2x upon 1 minus x square is equals to pi by 3. All right, you can do that. This is the property. Now this is 2 tan inverse 2x upon 1 minus x square. This is equals to pi by 3. So this implies tan inverse 2x minus x square is equals to pi by 6. Now what you can do?
Sir, but cortex is not in that form, right? Because it's in 1 minus x square by 2x.
No, see, we change cot inverse into tan inverse. All right, Shikani, please open property number 4 in your notebook where you have written that. Property number 4. Got it?
Yes, sir.
So can you read the properties? What is the first one, Shikani?
Sir, 1 minute.
All right.
Sir, which property?
Property 4.
Um,
I guess
sir,
this was,
tan inverse cot theta, that one.
right. Please read. I don't exactly remember if it was property 4. Can you read property 4? What was written there?
For in mine, I wrote tan inverse cot theta is equal to pi by 2 minus theta.
No, after that. See, let me give you the formulas for that again. Right. If you look at your notes, you will find somewhere the sine inverse x is equal to what happens if we inverse the reciprocal the angle here. Sorry, the value here. Krishna, what happens? Sine inverse x
Sir, cosec inverse x.
cosec inverse 1 upon x. And cos inverse x is
Sec inverse 1 upon x.
sec inverse 1 upon x. Tan inverse x is cot inverse 1 upon x. All right, Shekani, these are the few properties we have. So I used this property in here. Cot inverse of some angle. So if I reciprocate the angle, right, I will get tan inverse x. So by interchanging or reciprocating the angle, I can write cot inverse as tan inverse. All right, Shikani.
Yes, sir.
So now this value and this value is equal. So I can write 2 tan inverse this is equal to pi by 3. So tan inverse this is pi by 6. Now 2 ways we can solve this further. Either you can take this tan to this side. So tan pi by 6 is, you all know what is the value of tan pi by 6?
1 by root 3.
1 by root 3. Then you can solve for x. Otherwise, again, if you look at this is 2 tan inverse x. Right? This is 2 tan inverse x. So pi by 6. So this implies that tan inverse x is equal to pi by 12. So you can just find the value of tan pi by x will be tan pi by 12. So if you remember tan 15 degree from class 11th, this question is very easy. Otherwise, you can solve this from this also. Or you can find tan 15 again. All right. Is this clear or not?
Yes, sir.
All right, everyone.
Yes.
All right, note it down. Done, everyone?
Done, sir.
All right. So this is a new type of question, not very new or difficult. Like they just want to trick you by giving you this type of questions. So if they give you sine inverse sine x plus cos x upon something, all right. So what you can do here is, if you studied really good trigonometry in class 11, you know how to solve this. Anyone knows how to solve this?
Split the under root 2 sine x by under root 2 plus cos x by under root 2.
All right. And then,
And then sine x into 1 by under root 2.
all right.
That will be cos pi by 4.
Cos pi by 4. Right. So you have the idea how to solve this. Absolutely right. So what we can do here is sine inverse sine x upon root 2 plus cos x upon root 2. Any doubts in this? I just split, right? So this is sine inverse. I can write 1 upon root 2 into sine x plus 1 upon root 2 into cos x. All right. So this is sine inverse. I can write this as cos pi by 4 and sine x plus sine pi by 4 and cos x. right? I could have written this as sine pi by 4 also, this 1 upon root 2, but why not? Because we have sine inverse here. If we had cos inverse, and I would have written this sine pi by 4 and this as cos pi by 4. Why? Because sine a plus b has sine a cos b plus cos a sine b, and cos a minus b has, what is the formula for cos a minus b?
Cos A, cos B plus sine A, sine.
Right. So we need cos cos sine sine, right? So if we had cos inverse this side, then it would have written sine pi by 4. But here we have sine, so we can write this as sine inverse cos A sine B sine A cos B. So sine x plus pi by 4. Any doubts in this?
No, sir.
So this is equals to x plus pi by 4. Very easy, but this is a new type of question they can give. All right, note it down. Everyone is clear about this? Ishan?
Yes, sir.
All right, this is clear. Ronaldo?
Yes, sir.
Yes, sir.
All right, note it down.
So can you do a little bit of? Okay.
Done, sir.
All right, try to solve this question.
Done, sir. This one is also.
This one is
This is
done
very
very good.
easy.
I know, this is very easy. So anyone else can solve this? All right, if you remember the properties, then just by reading this question you can know how to solve, right? How to solve this?
Sine inverse can be changed to 2 tan inverse x, and cos
Right.
inverse is 2 tan inverse y.
Absolutely right. Right, Krishna, this is clear how to solve this. What is this
Yes, sir.
formula? Sine inverse 2x upon 1 plus x square. See, in inverse trigonometric functions, always start from this brackets. If you start from this side, nothing will be done. always start from the inside, right? So sine inverse 2x upon 1 plus x square. Can you imagine any formula regarding this? Just this. Ronaldo, any formula regarding this? Sine inverse 2x upon 1 plus x square.
Should be tan inverse.
Absolutely right. So I can write this as tan half. This is 2 tan inverse x, and plus any formula for this?
Should be tan inverse. Yeah.
2 tan inverse y. Krishna, this is clear?
Yes, sir.
All right. So you can see very easy. They just want to confuse you. This chapter is very easy. So this 2, 2, 2 we can cancel out. So this is tan of tan inverse x plus tan inverse y. So what we can do now? Krishna, what
Tan
we can do?
inverse x plus y by 1 minus x square.
Absolutely right. So this is tan of tan inverse x plus y upon 1 minus xy. So this is equals to x plus y upon 1 minus xy, hence 2. All right.
Yes, sir.
Note it down, everyone. Right. So this is the next question. Can anyone tell me how to solve this? How to solve this question? Nobody? If I give you this question, tan inverse 3 by 5 plus tan inverse 8 by 17, and I told you simplify, would you be able to solve this?
Yes, sir.
Why?
Formula.
So we can convert that sine to tan and then.
Right. So you get what I'm saying,
Yes.
right? So
Yes,
don't always think linearly. Always try to make the best use of whatever you have. Like be James Bond, right? Yes or no, Krishna?
Yes.
So make the best use of whatever you have. So we have this formula. So let's convert this into tan. Then we can easily solve, right?
Yes.
Everyone, this is clear. Kulsum, Said,
Yes, sir.
all right. Shikhani, Ronaldo, Ishan,
Yes, sir.
Yes, sir.
all right. There is one different way of solving this also. In fact, there is a formula for sine inverse A plus sine inverse B also, but not in your syllabus at all. So we'll not go through that. But what we can do is, let's say Sine inverse 3 upon 5 is A. So this will be equals to sine A equals to 3 by 5. Sine inverse 8 by 17 is equals to B, implies sine B is equals to 8 upon 17. Now we know the formula of sine A plus B. I told you always look at the right side. In right side we have sine inverse, that means we have to use sine formula. Sine inverse A plus B is sine A cos B plus cos A sine B. If we have sine A, we can find cos B, cos A. If we have sine B, we can find cos B. How? Cos A will be equals to 1 minus sine square A under root. So this will be 1 minus 3 square upon 5 square under root. So this is 4 by 5. This step is clear, everyone?
Yes, sir.
Same way we can find cos B. Cos B will be 1 minus 8 square minus 17 square under root. So 29, 64, 15 by 17, I guess. Please check. All right. Please, that's 89. Yes, 15 by 17. So we have 3 by 5 into 4 by 5 plus cos, sorry, 15 by 17 plus cos A is 4 by 5 into sine B is 18 by 17. All right, you can check this answer and then you can take the sign to that side. A plus B will be sine inverse as well. All right, so this is 85, 85, 15 3s are 45, 8 4s are 32, 45, 77. Yes, 77 by 85. So we have A plus B as sine inverse 77 by 85. And what is A? Sine inverse 3 by 5. What is B? Sine inverse 8 by 70. So we have the LHS equals to RHS. This is clear?
Yes, sir.
All right. So you have to do the same thing. The effort is same. So whatever method you prefer, that is okay. This method is clear to everyone? Yes or no?
Yes, sir.
Yes, sir.
All right. Note it down. And please, in homework, solve this by the tan method also. Convert this to tan and solve. Done?
Yes, sir.
All right. Next question. We have 9 pi by 8 minus 9 by 4 sine inverse 1 upon 3 equals to 9 by 4 sine inverse 2 root 2 by 3. We have to prove this. So let's start from LHS. We have 9 pi by 8 minus 9 by 4 sine inverse 1 upon 3. So what we can do here, we can take 9 by 4 common. So this will be pi by 2 minus sine inverse 1 by 3. This is clear. I just took 9 by 4 common. Now what we can do, we know that sine inverse 1 upon 3 plus cos inverse 1 upon 3 will be equal to pi by 2. Yes or no?
Yes, sir.
So pi by 2 minus sine inverse 1 upon 3 I can write as cos inverse 1 upon 3,
Yes, sir.
right? So this will be 9 by 4 cos inverse 1 upon 3. This step is clear, everyone?
Yes, sir.
Ishan, this is clear? All right.
Yes.
Now we have to convert this cos inverse 1 upon 3 to sine. So how we can do that? How to convert this cos into sine?
So we take cos inverse 1 by 3 is equal to a like that.
Absolutely right. So we take cos inverse 1 upon 3 equals to a. So cos a equals to 1 upon 3. Let's make a right angle triangle, or you can directly use the formula. I like the triangle more. So this is 1, this is 3. So this will be 2 root 2. So sine a will be 2 root 2 by 3. So a will be sine inverse 2 root 2 by 3. So this is simply 9 by 4 sine inverse 2 root 2 by 3. All right. Not a lot of efforts needed. Everyone, this is clear. Kulsum, Shahid.
Yes, sir.
All right. Note it down. Done.
Yes, sir.
Solve this one. Cot of tan inverse a plus cot inverse a. Find the value. We have to find the value of this total quantity. Anybody has the answer?
Tan inverse x plus cot inverse x is pi by 2.
Right.
So
Right.
it can be cot pi by 2.
Absolutely right. And what is the value of cot pi by 2?
0.
0. So the final answer is 0. Very easy question. Right? We don't even have to think. Tan inverse A plus cot inverse A is pi by 2. So cot pi by 2 is 0. Clear?
Yes, sir.
All right. No need to change. If somebody had this in mind that tan inverse 1 upon A, then let's use tan inverse X plus tan inverse Y, right? Krishna,
Yes, sir. You read my mind.
right? You're thinking like that.
Yes.
No need to think like that. All right. Sometimes you just have to look at the question, right? See, if you think a lot, then there is going to be a lot of trouble, right? Think when you are doing the practice. All right. Read the question, see what the question is saying, like talk to the question. Then that is very easy to solve. All right. We learn in the way, whole process. Let's solve another question. This question is clear to everyone? Ronaldo, Ishan?
Yes.
All right. Let's solve another question. 2 sine inverse x is equals to sine inverse 2x upon 1 minus x square. All right. You have to prove this one. Again, as I told you, very easy to prove. Always assume the right and left hand quantity. So sine inverse x, let's assume theta. So this implies sine theta is x. Now I have told you this also. Always take the formula for what is in the right side. So in the right side we have sine inverse. So what we can take, and again we have 2 sine inverse x. So sine 2 theta is 2 sine theta cos theta. This is clear.
Yes, sir.
All right. Why I took sine 2 theta and everything. So this we can write 2 sine theta, and cos theta I can write under root 1 minus sine square theta. No issues there.
No, sir.
All right. So 2 sine theta is, I guess, x, and under root 1 minus x square. So we have 2 theta equals to sine inverse 2x under root 1 minus x square, and theta is, we have assumed, sine inverse x. So 2 sine inverse x is equals to sine inverse 2x under root 1 minus x square. This is clear.
Yes, sir.
All right, very easy question. Note it down. All right, these two questions are for homework. All right, and in the next class you will have a test of inverse trigonometric function. All right.
Yes, sir. So for the second homework question, we should use sine 3 theta.
This one, the last one.
Yes, sir.
Yes, sine 3 theta you can use, right?
Okay, sir.
And in the next class, everyone please revise differentiation. All right, differentiation of class 11, the basic differentiation quantities, right? Differentiation of cos x, sin x. You are all science students, I guess, right?
Yes, sir.
So you know all the basic differentiations. I don't think we need to revise that. But if somebody doesn't remember the formulas, basic formulas, and please revise that. In the next class, we are going to start continuity and differentiability. All right. Is it clear, everyone?
Yes, sir.
Yes.
Yes, sir.
All right. Ishan, Shikani.
Yes, sir. Clear.
All right. So I hope there is no doubts in this chapter.
No, sir.
All right. And still, please revise. And I'll give you one assignment also. Solve that. Prepare for the test. All right. And see you in the next class. Take care, guys.
Sir,
Yes.
sir, in the previous assignment,
All right.
that the first question was like evaluate each of the following. It was sine inverse of sine pi by 3.
Sine inverse sine pi by
Sine
3.
pi by 3. Yes, sir. Sir, both the signs were inside the bracket.
Right. I think this was a mistake because we can solve this, but let me tell you how to solve this. You will not be getting exact value because why? We can write the sine inverse sine. What is sine pi by 3?
Root 3 by 2.
Root 3 by 2. Now, to find this, you can write this answer. Sine inverse sine is root 3 by 2. All right.
Yes, sir.
This is clear. But please focus on the domain and that also. So there is no issue of domain here. So I guess we can get the answer. All right. Clear?
Yes, sir. Thank you, sir.
All right. Any more doubts?
So there will be test on the next class, right?
Right. In the next class, there will be a test. All right. So prepare accordingly. Remember all the properties, all the questions, and most of the questions we have already done in the class. So if you revise well and finish NCRT also, you will be fine in the test. All right. So take care. This is all for today's class.
Thank you, sir.
All right.
Thank you, sir.
Thank you,
All
sir.
right.
Thank you, sir.
All right.